Okay, so that one. And then, for example, something like this. So I'm a little bit worried about the language of the question different people are writing and how I am teaching. So I'm just emphasizing here. So that, oh, we didn't study in the class, so how this question comes, and so I just wanted to emphasize something. But the material is same, yeah. The concept, the content is same. Just the question, how the questions are worded. So another one is like, okay, so let's say I have the a compound like this, B2O4, B2. O6, B4, O8. So these are the same compound, BO, right? So which is the same empirical formula here. So meaning that the lowest ratio, you are going to get the lowest ratio. So this would be B1 O2, right? So if you divide both by 2, that will be B1 O2, right? And then for this one, if you divide by 2, the lowest number, you will get B3O3. And if you divide the lowest number this by 4, that would be B2O2, right? You see that? So this is the input. So which one is same? This one, and this one has same ratio. You see that? Yeah, this is B1. Sorry, B1O2. You see? So you just take a small number, divide that, and if you see the same number of ratio, that is called the empirical formula, right? So something like this. Make sense? So you see, so I just if I had to teach myself and take all question myself, I would just give the question how exactly I taught in the class, and I would give that way. You see that? So, but since we three are coming together, so maybe the questions are worded differently, so you might get confused a little bit. Yeah, but the question is not BO there. There's something else, maybe C2H9 or whatever, right? But I just wanted to give that idea. Okay, so another thing is something like this. You might see the question like this. So let's say I already teach this equation to you. AL plus BR2 gives you AL2. If you look at the previous slide, AL2, BR6. You see, so this is the equation, right? So aluminum is reacting with bromine, AL2, BR6, right? And then the question might have, this is not the question. This is not the exam question, yeah? So this is just how I'm, the questions are worded. So like this. So it might have given you, so okay, what makes this equation balance? Maybe 2, 3, 1, or 3, 2, 1, or 4, 2, 1. So which, so this you might have to choose 3. So maybe A, maybe B, maybe C. So you see which is good here. So you're just going to put either this set of number here, 2, 3, 1, or you are going to put this set of number here, 3, 2, 1 there, or 4, 2, 1. So which one makes the balance? So you just put those numbers. Maybe if you put this 1, 2, 3, and 1 here, it's already balanced. See that 2AL here, so AL2, 2 multiply 1, 2AL. So 3BR is 6, BR already 6. So that makes this equation balance. Make sense? So you might have to pick from this. So maybe there are many questions. So just you have to look which of this makes that balance. Yeah, good. So you can practice in home, like I put in the PowerPoint slide today. So you can just look those kind of questions. These are not the exam questions. So I just wanted to say that what is expected in exam. Yeah, good. So yeah, then we can easily do those things. And now I start today's chapter. So if there is not the exact, somebody is, I don't think it is his fault, but it would be nice. So I don't know what. Can somebody speak if you are typing your message? How much time is? It's 1 hour, so I think there will be plenty of time. So time is not a big deal. I just wanted to emphasize if you understand the question, what it is being asked in the question. Yeah. So sometimes you know everything and you just get confused during the exam. Yeah. So So that's it. So all right. So this is similar to. Will the teacher? Yeah, if I have made this question self, it would be look like very similar to homework. But since three people are making the question, maybe there is some dissimilarity. That's why I'm a little bit worried. You see that? So maybe I emphasize something greatly here, what you should understand. So maybe the question from other professor might be ordered a little different. But they look. I think the knowledge that I teach here, you should be able to do those. That's nothing new there. Yeah. Good. So we agreed on those things. Good. So, so slip those, and you will see which is balanced and which is not. Those kind of things. So the question might ask you, maybe this one is giving like this. So one may be giving like this, another may be giving like this. So CAL 5 BR2 3 AN2 BR6. So maybe you are given three equation like this, yeah? And the question might ask, which one is balanced? Is this a balance? Is this a balance? Or that one is a balance, or that one is a balance? So you're just quickly going to, okay, 2AL here, 2AL here. Okay, this is this balance. So 3 to 6 is, VR6 is a balance. So this is the balance. So if you look here, 3AL, 3AL here, 6AL here, 3 multiplied by 2. So it is just, so you don't have to do everything. So just quickly look in some of the atoms. Is the AL balance here? Yes, AL maybe it's good, right? Then look here. Okay, already done. So you don't have to look other. This is look few things, and then you can easily identify which one is balanced or which one is not balanced. Just the strategy, yeah. Make sense? Good. So. So I put there's a lot of those questions, so maybe you can practice in home in today's slide. Yeah. So you just look it and which one is balanced. Just looking just one element, you will easily know. Okay, you don't have to just look Al 3L. Maybe it's already there. Al 6L. Yeah. So and if it is balanced, maybe you want to look here and here. Okay, this is 5 BR 10. This is 3 6 18. Not 10 and 18. Not good, right? So just look few things, and then you can identify which one is balanced and which one is not balanced. All right. So yesterday's class was a little bit rough. The last class I broke my computer. Now my computer is working, so I have to repeat a little bit. Yeah. So we were talking about the equilibrium. So if you mix hydrogen and fluorine together and react this reaction, there is all hydrogen and all fluorine is gone. So like this, you see that this is a kind of only product for favor reaction. So there is no equilibrium here. There is no, so hydrogen and fluorine, this molecule is not going to break to give H2Cl to itself. Yeah. So for example, H2 plus O2, if you burn hydrogen in oxygen, you get 100% water. There is no going to be left hydrogen in oxygen here. You see that? So completely water is formed. And water itself cannot break to give hydrogen in oxygen. If water itself break in hydrogen in oxygen, we go to the lake, and all lake would be decomposed into hydrogen and oxygen and would have been gone, right? So water cannot do that. So only this is a one-way reaction. See, hydrogen and oxygen combine to give water, but water cannot break to give hydrogen and oxygen itself. We need to break by somehow by putting electricity. Yeah. So this is not reversible reaction. This is not reversible reaction. But if we are doing something like this, let's say nitrogen plus hydrogen. Last class, so this is ammonia. So it's like this. So nitrogen, if we mix the nitrogen and hydrogen together, if they are giving ammonia, and at the same time, when ammonia forms, ammonia is breaking to give the nitrogen and hydrogen. So this kind of reaction is called the reversible reaction. Yeah. So this is the reversal. So reactant adapting to the product is breaking to give the reactant. So this is continuously going on process inside that reacting vessel. Yeah. So this kind of system is called the dynamic equilibrium. Yeah. So continuously ammonia is breaking to give nitrogen and hydrogen. Continuously nitrogen and hydrogen is reacting to give the ammonia. Yeah. So this kind of reaction are called reversible reaction. Reversible reaction. Reversible meaning that they go forward, they go the backward, both way. Yeah. So, and if you see these two arrows, that means that it is in the condition of equilibrium, meaning that how many molecules are decomposing and how many molecules are going to give this one, that many molecules are decomposing to give this one at that condition. Yeah. So to begin with, maybe many ammonia is being formed. No ammonia is being decomposed at the beginning, but after a certain time, maybe after 10 minutes, 20 minutes, so number of ammonia being decomposed and number of ammonia being formed is same. So from here, number of ammonia is being formed and number of ammonia being decomposed at that condition becomes equal. So that is called the reversible condition. So I put the one homework problem, you can see that. Yeah. So what is the reversible meaning? Reversible meaning that going backward and going back is exactly at the same rate. Yeah. So it's just like from if I go from my here to my office 10 minutes, 5 minutes, from there to come here is a 5 minutes. So it's kind of the reversible. Yeah. But if I to come here is a 10 minutes, I go back is a 5 minutes, that's not reversible. You see that? So the rate is not same. So the double arrow shows the equilibrium. And I talked about the electrolyte. So electrolyte meaning that any chemical you put in a pure water and that conduct electricity, and they are called electrolyte. For example, this is a very pure water, and you connect some two electrode here. So this is one electrode, this is another electrode. So you can put a ball here. So you can connect this with the battery. This is a battery. See that this is a battery here. This is battery. This is plus. This is minus here. So this is battery. Yeah. So this is battery and here. This is water here, and you connect with this wire a ball here. You see that? So if it is a pure, this ball is not going to give light. You see? So that's not electrolyte. Pure water is not electrolyte. So pure water is not electrolyte. But now put some sodium chloride here. Sodium chloride here. Now this light start to give light. Yeah. So the sodium chloride conduct the electricity here. That gives Na plus and Cl minus ion, and so this is called the electrolyte. Instead of sodium chloride, you could put something like HCl. Same. So it's H plus and Cl minus ion comes here, and this make the water conductive, and then the light start to give light. Make sense? So that they are called the electrolyte. But if you put a vinegar instead of HCl, NaCl, those compounds, if you put this compound called vinegar, it gives a very small number of CS3, COO minus and H plus. So this is called the weak electrolyte. So this gives the light, but it gives the dim light. Yeah. So how do we know some are strong electrolyte and some are weak electrolyte? So if you inorganic compound like the NaOH, LiCl, HCl, no carbon here, right? Do we see carbon here? No carbon, right? So this kind of the compound are strong electrolyte. Make sense? But if you see something like the CS3COH, CS3CH2, COOH, you see, if you see something like this, they are weak electrolyte. Organic compound are weak electrolyte. Yeah, make sense? So this kind of thing are weak electrolyte. So they don't conduct electricity that much. So this light is dim light. But this kind of compound called inorganic compound, so when you dissolve those, they conduct electricity really good, and this is very bright light. Yeah, good conductor. They give good conductivity. So in the next lab, we will be doing in Chem 106 like this thing. Yeah, and then for example, maybe you put the alcohol here. So you didn't put this acid or those compound here. You just put the alcohol. Like alcohol is this compound CS2OH. So if you put the alcohol here, so drinking alcohol, so it doesn't the light is not giving any light. So meaning that it doesn't conduct electricity. So this is a bad conductor or non-electrolyte. Non-electrolyte. Make sense? It's a very simple test. If something is electrolyte or not. So to get a pure water, connect the light bulb there and connect the battery there, switch on and put NaCl. Light is very bright. So that's a sodium chloride is strong electrolyte. Do the same experiment another time, put some alcohol. Now the light is not giving any light. So that's a non-electrolyte. Put the vinegar a little bit there. The light is giving dim light, yeah, not bright, but it is giving light. So that's the weak electrolyte. That's how we can easily identify something is weak electrolyte, strong electrolyte, or the non-electrolyte. Yeah. But nowadays we have to do light because we have a sophisticated conductivity conductance measuring devices, so they can give the number. Okay, this is the number, this is the number, this is the number for strong or weak electrolyte. Yeah. So those kind of thing there. Now that is this one. Now let's talk about a couple of things here. Some example here. Is sodium chloride strong electrolyte, weak electrolyte, or non-electrolyte? So sodium, look the periodic table. In the periodic table, sodium is in +1. Yeah, so all the way to the left. And chlorine is in the 7, so that is -1. So this kind of compound always are strong electrolyte. Make sense? So let's talk about the hydrochloric acid like this one. Look again the periodic table. Where is the hydrogen? All the way left, right? So +1. All the way right, -1. This is when once we put them in water, it's just break and gives this ion, and this ion they separate and they conduct the electricity. Very good, strong electrolyte. Yeah. So let's get another one. Magnesium chloride. Where is this one? All the way to the left in the periodic table, right? And this is the all the way right. So once we put this ion in the water, it immediately breaks and gives magnesium to a chloride ion, and it's also a strong electrolyte. So if you see all the way on the right element and all the way to the like this the seventh group, chlorine, fluorine, bromine, when those kind of things are attached to the group 1 or group 2 element, they are very strong electrolyte. They once we put it, immediately dissolve. For example, sodium chloride is a table salt, right? That we use in kitchen. So you put the some sodium chloride in water, they immediately disappear, right? So they give the sodium and chloride, so that they are strong. Other compound like H2SO4, this is an acid. This also works as a strong electrolyte. When we put it in water, it gives hydrogen ion and sulfate ion. Sulfate ion. So this is also strong. So ionic compound, one of the compound which has a charge, and once we put in the water, they immediately dissolve and give the ion. They are strong electrolyte. Yeah. And what are the weak electrolyte? You look something like this. Carbon. Look, what are the weak electrolytes? Most of the time, weak electrolyte are CS3COOH type compound. You see, so something like this. These are the weak electrolyte. Yeah. So there is a carbon and there are a couple of oxygen there. Yeah. And what are the non-electrolyte? It's something like this. You see, it cannot break to give into ions. CS4. All other organic compounds are non-electrolyte. CH4. Cl4. So you see that C is in the fourth group, Cl is in the group. So they also don't have charge separation there. You see, now CH4, Cl4, CH3, CH2OH. So something like this. If there are double O, they are weak electrolyte. But if there is single O, they don't conduct electricity either. Yeah? There is a carbon and there is a single O. So this kind of compound can break to give the ions. Yeah? So this is bad conductor. But this is weak conductor, weak electrolyte, non-electrolyte. Non-electrolyte, this is also non-electrolyte. This kind of the compound are non-electrolyte. You see? So the carbon there, and with the carbon, maybe some chlorine is attached, maybe iodine is attached, or maybe hydrogen are attached, all are non-conductor. Yeah, but if there is a carbon and you see OO group there, they are most of the time they are the weak electrolyte. Make sense? This material is too much. We need to know on organic chemistry, inorganic too much. So just to understand that much now. Yeah, good. All right. So how about this one? CH12H22O6. So this is a this is the sugar we eat in kitchen. Sugar. Yeah. So if you put the sugar, that also don't give any ions. You see, I told you if some only this COOS, this type of compound are weak electrolyte. This gives the ion. So if you have to break this compound, it will give you CS3COO minus and plus H plus. It gives like, but this sugar cannot break like that. Yeah. So this is non-conductor. Sugar cannot non-electrolyte. Sugar solution cannot conduct electricity. So if you take a beaker, put a sugar, and put 2 electrodes and connect with the battery, the light doesn't give light. Make sense? So sugar doesn't conduct electricity. So that's a bad. So for example, anyway, where is Na? Na, where is Na? All the way to the right of the left of the periodic table. Anyway, you see. So these kinds of very good electrolytes. So the first group in the periodic table, and they are combined with something else. Very good electrolyte. Yeah. Group 1 and group 2, they give very good kind of electrolytes. So magnesium, sodium hydroxide, maybe potassium hydroxide. So you see that this is also in the group 1, right? And so this is gives plus and this gives minus. So these are very good electrolyte. Yeah. Yes.
So it's because of the charge.
Exactly.
Like, but it's like positive one and like negative one because.
The only charge cannot do that. We will talk a little bit further later. First of all, they need to dissolve. If they dissolve, and then they are the electrolyte. This kind of thing.
So,
if they don't dissolve, the particle cannot separate to move. Like for example, let's say you take magnesium oxide, right? So we talked in magnesium oxide in the last class. So you take the magnesium oxide. So if you put the magnesium oxide, it has a +2 charge, it has a -2 charge. You see a lot of charge, right? But it doesn't dissolve in water. The magnesium and oxygen cannot move around. They just stick together. So even though this is like a lot of charge there, but those charged particles cannot move freely. They stick together. If they stick together, they don't dissolve. If they don't dissolve, they can't carry the charged electrons. Make sense? So two things. First of all, compound should have ions, and when we put in water, this should be able to break like this: Mg2 plus and O2 minus. You see that? Sure. But for example, if you see iron oxide here, so this has a +3 charge. If you separate the charge, this has +3. This foot comes from this 3, right? 3 charge. And OH has 1 charge, so there is nothing here. So 1. So OH has a -1 charge. Lot of charge. But if you put FeOH3 in water, it doesn't dissolve. So FeOH3 Fe and OS cannot be moving separately. So they always sit together, and when the ion cannot move, that cannot be the electrolyte. So what is the requirement for the strong electrolyte? First of all, they need to be able to dissolve in water, and those ions should be able to be separated to move. Yeah. So don't go too deep. If we start to go too deep, it's very confusing. Yeah. So we just look a few examples here. Now, so what we have here is, I already talked about the acetic acid. So there is a carbon there. So this is a weak electrolyte there. Okay. Now, reaction in aqueous solution. What is reaction in aqueous solution? So reaction meaning that a reaction, two things are reacting together to give the new products, right? And then in aqueous solution means aqueous, QUOUQE, I don't know, aqueous solution. Aqueous meaning that water. So we are doing the reaction in water medium. It's called aqueous reaction in aqueous medium. Make sense? So we have water. We are throwing something in that water, and then because of that, the water dissolves those things, and these particles of different substance can come in contact, and they just rearrange. Yeah. So one goes to stick with one, another stick to go with another, and they give the new product. So this is called the reaction in aqueous solution. So what happens if we do the reaction in aqueous solution? Give precipitate. You see that? So let's say this is a test tube, and you have some water and sodium chloride. You see that? This is water. In water, you have some salt, and you dissolve it, and you can't see salt with your eyes, right? Now, let's say I have here is a silver nitrate, AgNO3, silver nitrate. So this is also water, and I put some silver nitrate here, and I dissolve, and so I cannot see with my eyes. It is also solution, right? So if I put this solution here, I take some solution and put it here. Immediately I see some solid here like this. Make sense? So that solid is made coming from like this. You see? So I had NaCl. Now I put there AgNO3, and what happens is that they start to exchange. So this guy, you see, this is plus. I told you the front one is always positive, right? And the latter one is always negative. So negative goes to sit with this positive, and this negative goes to sit with this positive. Make sense? So they are just exchanging the position there. So you see, sodium goes to sit with nitrate. So that is NaNO3, and this chlorine goes to sit with silver. So AgCl. You see that? Now this guy, this can be dissolved in water. So you can see this one. This cannot be dissolved in water. So this comes as a solid. Make sense? It's just changing the position. Yeah. So one goes to sit with the other. One goes to sit with the other in water. So this is called the double displacement kind of thing. One is displacing other. Yeah. So we call this solid as a precipitate. Precipitate. So if you mix two solutions together and if you see some solid, that is called precipitation reaction, and this solid is called precipitate. It's very important. Yeah, make sense? So good. Sometimes the reaction gives gas. Sometimes it gives the weak electrolyte. So that's okay. You don't really have to understand here. So the most important thing for the exam and the other purpose also, I'm going to talk this solubility rule. Yeah. So this is the 11th slide. So I'm going to talk. So if we mix something, at what time or what thing I mix here to see the solid? Yeah. When do I which one thing I can mix with another so that I can see the solid? So I already told you, if I mix silver nitrate with the sodium chloride, I'm going to see some solid here, and that is the AgCl solid. Yeah. So this is not solid. This is aqueous. This is completely dissolved into ions, NaNO3. Yeah. So that breaks. Make sense? So see, here is this is very important. So for exam, this is slide 11, maybe slide 12, slide 13. They will be very helpful during exam. Yeah. So just make notes. So you see, if you see that, if you see that this slide number 11, you will see soluble compounded here. Soluble compound, soluble compound, soluble compound, soluble compound. So if you see sodium, potassium, ammonium, sodium, potassium, ammonium, and something combined with them. So this is the only ions, right? There's something is combined with them. So what can combine with them? So nitrate. I'm just looking the first box of this slide 11. Sulfur nitrate. This one is chlorate minus, and then ClO4 minus, and CS3 COO2 minus. Yeah, CS2 sorry, minus CO2. They write CO2 or COO, the same thing, yeah? COO or CO2 is same. So the first box is saying something like this. So meaning that you combine this guy with this one, sodium nitrate, right? Plus and minus. So what is this one? Sodium and nitrate, NaNO3. So this is completely soluble in water. That the box that is saying is that this guy combined with this guy becomes this one, and 100% soluble. Put in water, it immediately dissolves and gives sodium and nitrate. Make sense? And then combine this one with this one, potassium nitrate. Again, same thing. It is completely soluble. Ammonium and nitrate. So ammonium nitrate, completely soluble. You see, ammonium nitrate, all soluble. The compound made from this and this one, completely soluble. Compound made from this and this, completely soluble. This one, this, put in water, completely soluble. Make sense? That's what it is saying. And then, now we are done with this one. Now let's look another one. So, this sodium and chloride make a compound from this one too. So, sodium chloride. this one, sodium chloride or chloride, sodium ClO3. You see this compound, 100%. You just put in water, just disappears. So that's the first box is saying the same. Yeah. So you combine this ammonium with this one, so that becomes CS3COO, and NS4 comes to sit with this one. So this sits with this one. So this compound is also put in water, it dissolves 100%. That's what it is, the box one saying. Make sense? So combine any positive with any negative of that first box, that compound immediately dissolve in water. Yeah, that's what it is saying. Now let's go to the second box. If you see anywhere in the second box, what it is saying is, if you see anywhere like this one, let's say Cl, Br, and I, this one, in the second box, this is saying this one. If you see anywhere this guys, anything that is combined with this one immediately dissolve in water, right? So let's put some positive here. So let's say NaCl. Let's say this one is potassium. So this is one compound. This is another compound. Let's say Ki. You see that? So these are negative. Chloride, bromide, iodide. They are negative. So you can put anything in front of them, and those compounds all are soluble in water. That's what it is saying. Make sense? So we are giving the ion, chloride, bromide, iodide. So combine those ion with any positive ion and make a compound. That compound is going to dissolve in water. That means that, yeah? Confusing? Yeah, once you look the more and then you will understand. Now, if the box, go to the toward the lower side and you will see in top, it is like this. In the box 2, it is saying this, Cl minus, Br minus, and I minus. You see, at the top, it is saying this one. And the bottom, it is saying exception, exception, exception. So it is giving exception Ag plus Hg2, Hg2, 2 plus, and Pb2 plus. It is saying that. What does the exception mean? So combine this guy with this guy, that doesn't dissolve. Exception meaning that doesn't dissolve. Yeah. So what can dissolve? We already talked. What cannot dissolve? Now you see, AgCl doesn't dissolve. AgBr doesn't dissolve. AgI doesn't dissolve in water. HgCl, this compound is a little bit difficult. You see, I write here Hg2, then 2 here, and Cl minus 1 here. So this ion I am combining with this one ion, right? See, now this guy come here, and this one goes down here, so it becomes Hg2, Cl2. So this compound doesn't dissolve in water. But if you see any other thing except Ag, Hg2, and Pb, with this one, they dissolve. So maybe you can get some idea, okay, these things are not compatible with these things, or something like this, yeah? Or maybe more compatible with these things. So maybe Ag married chlorine, they never separate, so they don't dissolve. Maybe you can make some kind of the story yourself, yeah? So if Ag combined with Cl, that becomes AgCl, and that never dissolve in water. Make sense? If Hg2 combined with Cl, that Hg2Cl2, that never is, yes.
Sorry, with the on the graph, we were talking about the exceptions. Will with the 3 on the bottom, so Ag plus, Hg2 plus, and Pb, will they only not dissolve with chlorine, bromine, and iodine?
Yeah, correct. Exactly. That's what I'm saying. Yeah.
Okay, just those specific
Yeah.
ones?
Yeah, because people have done a lot of experiment and they found this one. There is no other. Make sense? So there are 9 compounds possible, right? AgCl, AgBr, AgI, Hg2, Hg2Br2, Hg2I2, Pb2, PbCl, PbBr, PbI. There are 9 possible compounds there, right? So when you start to combine 3 with another 3, that gives you a 9 compound, right? So they are all insoluble. Make sense?
Yes, thank you.
Very good. Now, it's a good question. Now, go to the third column here. Go to the third column, and in the third column it says all salts containing fluoride are soluble. So maybe KF, you see, KF and NaF, NaF. So this is fluorine. So this is positive, this is negative, positive, negative. All compounds containing fluoride are soluble in water. Once you throw those into water, they are soluble, right? In the third box. But what it is saying is exception: magnesium with fluorine, not dissolved. Calcium with fluorine, not dissolved. Strontium with fluorine, not dissolved. Barium with fluorine, not dissolved. Lead with fluorine, not dissolved. That's what it is saying. Exception. Make sense? So you see, if you look the third box, it is saying the fluorine at top, very important for exam. So fluorine here in the third one, and then it is saying exception. Exception. So exception is magnesium 2 plus calcium 2 plus strontium 2 plus, and then I have a barium 2 plus and Pb 2 plus. You see? So how many compounds you can make with this one? Magnesium fluoride, calcium fluoride, strontium fluoride, barium fluoride, lead fluoride. You see? So how many compounds you can make? 1, 2, 3, 4, 5. All these are insoluble in water. That means that. Make sense? So if you see something like this, would be magnesium 2, fluorine 1. So we come like this, and then that becomes MgF2. Is it soluble or not soluble? Not soluble. That's what it is saying. Make sense? Yeah, it's confusing. It will make sense later. Yeah, when you repeat couple of times and it makes sense. Now, same thing. How about the lead? Pb 2 plus. So Pb 2 plus. Now combine Pb 2 plus with the fluorine 1. Then this comes down here. This goes down here. So that gives you Pb 1, fluorine 2. So this compound is not dissolved in water. Make sense? Exception meaning that they don't dissolve. You start to combine, and whatever you get the compound that doesn't dissolve in water. Yeah. So hopefully you can do something there. Now, how about let's go to the last column, the fourth one. It is so how this we got the precipitate by mixing silver nitrate with sodium chloride already. We are just doing the same thing. Yeah. Now salt of sulfate. Oh, dissolve. So combine with potassiums, it dissolves sodium. Anybody know what chapter? This is the chapter 3. Yeah. Now, see now combine this with the sodium. You see now this is sodium is 1, sulfate is 2. So 2 comes here, 1 comes here. So that is Na2SO4. So this is soluble. It's 100% put in water. It's a strong electrolyte. It immediately dissolve. If you try to get the light bulb there, it gives a very bright light. Very good. Yeah, happy. So how about this one? Now go down to the exception: calcium, strontium, barium. Again, calcium 2, strontium 2 plus, barium 2 plus. So and then Pb 2 plus and Ag plus. You see? So if you combine this guy with this guy, it is not going to dissolve in water. Calcium sulfate doesn't dissolve. Barium sulfate doesn't dissolve. So does it dissolve? Does it give solid, or it is it's clear liquid? So barium 2 and sulfate 4. You see? So this comes here, this comes here. So since 2 and 2, we don't write the same number. So BaSO4. Does it dissolve in water? It is saying that that's exception. It doesn't dissolve. So whatever you see here, barium sulfate doesn't dissolve, calcium sulfate doesn't dissolve, strontium sulfate doesn't dissolve, lead sulfate PbSO4 doesn't dissolve, and AgSO4 doesn't dissolve. That's what it is saying. Exception meaning that whatever the ions, positive ion and sulfide combined together, it is not going to dissolve. Exception. So somebody is typing a message here. Let's see. How do you know if it can or? Yeah, that we don't know. So we need to look at the charts. Once this dissolve, this inorganic compound, they immediately give the ions. How do you know if it can or can't dissociate? It can dissociate. If it is dissolved, it dissociates because these are ionic compounds. But if it doesn't dissolve, then it's impossible to dissociate. Yes.
So we have access to something like that as a guide for the test?
Yeah, everything is accessible. Just print everything like the molar mass, the periodic table, everything is accessible. So only Dr. Cook is saying we need to use the lockdown browser or something. I'm working on that. I'm new myself. So you will have to use that browser. I don't know how it works. I need to work on it. But everything is there, yeah? So whatever is you need, periodic table, dissolubility table, it's impossible to know these things without tables. Yeah? So just use this. Make sense? Yeah.
So are we gonna get like a package that we can print out of everything that we need, or is it like an open note?
It's an open note. It's whatever you need, just you make ready. Probably your computer doesn't allow to go other way during the exam. So be ready previously, yeah. Or maybe you have two computer in home, so maybe probably Google in one computer. I don't know what. Yeah, good. All right. So yeah, this is the examination doing like three professor coming together the same set of questions looks a little bit difficult to me. So I think we emphasize one thing in class, but in exam the questions are worded differently, or maybe as a student become a little bit upset. So that's I wanted to just mention. Yeah. So let's see how it goes, and if it goes okay, if it go, and we will see. All right. So then let's look at slide number 12. We still have some time. Uh, Slide number 12. So you see what it is saying is that the first column it is showing if some compound has carbonate 2 minus and PO4 phosphate 3 minus, ultralight C2O4 2 minus and CrO4 2 minus S2 2 minus. If something is reacted with these things, that is insoluble. So put iron here. Maybe put your iron. Maybe put copper. Maybe put calcium. Maybe you can put barium. You see, these uh, all. You see, this if something is connected with these ions like this, they are all insoluble. That's what this slide 12 is saying. Yeah. But again, there are some exceptions. Yes, you see, now there are some exceptions. So at the bottom, you will see some exception. So what it says is that ammonium NH4 plus, NH4 plus ammonium and alkali metal cations, meaning group one. So you look the periodic table all the way to the left, and those group one ions and barium sulfide. So these are dissolved. So for example, what this exception is saying is that now I delete this one and then I'm going to put ammonium here. Dissolve. Exception. It dissolves. Previously I write iron carbonate, that doesn't dissolve, right? Or barium carbonate, that doesn't dissolve. Now exception, I am going to put these things here. It dissolves completely. Now group one, so I am going to group one is look the group one, maybe potassium, sodium, rubidium, right? So put sodium here. This compound is dissolving. Make sense? And again the same thing. So group one, I put the sodium phosphate here, it dissolves. But if I put other, maybe barium phosphate, it's the second group, it doesn't dissolve. Those are exception. From group one element combined with these ions, they are dissolving. Make sense? So that's the exception. And then another compound, this compound, barium sulfide dissolves. The sulfide, other sulfide don't dissolve, but this barium sulfide dissolves. But group one sulfide dissolve, maybe potassium sulfide dissolve, but because that's the group one. But this barium is from the second one. Barium sulfide dissolve, but maybe magnesium sulfide doesn't dissolve. You see that? Barium sulfide dissolve. So that's exception. Make sense? So look those exception and what doesn't dissolve. And now I have another column there. Most metal hydroxide and oxides don't dissolve. So you see, most metal hydroxide and oxide. So don't dissolve. So don't dissolve. Most metal hydroxide. Let's say this is iron is a metal, right? Yeah, iron is a metal. So I want to combine with oxygen. So let's iron and oxide. So oxygen is 2, iron is 3. So 3 comes here, 2 comes here, Fe2O3. So metal oxide don't dissolve in water. Most metal oxide don't dissolve in water. How about hydroxide? So let's say this is a metal. I put with the hydroxide. So maybe this is 3. This is 1. And 1 comes here, 3 comes here. So that is FeOS3. So this is also metal hydroxide. So it doesn't dissolve in water. So most metal hydroxide and oxide don't dissolve in water. So what dissolve? There is also some exception. So go to all the way to the left of that periodic table, look the group 1. So they all hydroxide and oxide dissolve in water, you see. Now in periodic table, sodium is a group 1, and oxygen here. Now, so oxygen is 2, sodium is 1, so it comes here, so that becomes Na2O. Now this oxide dissolve in water. So group 1 oxide, group 1 hydroxide dissolve in water, but other oxide and hydroxide don't dissolve in water. Make sense? So that's this table is saying. And then exception, alkali metal hydroxide, and in the group 2 also, these two hydroxide, barium hydroxide and strontium hydroxide, these two hydroxide also dissolve. You see that? This is from the group 2, and these two dissolve, and all group 1 hydroxide oxide dissolve, and these two also dissolve. So magnesium hydroxide, they don't write, so maybe it doesn't dissolve. So magnesium hydroxide doesn't dissolve, barium hydroxide and strontium hydroxide dissolve. So in future, when we look the periodic property, we will just going from top to bottom, what can dissolve, what cannot dissolve, we can discuss. So that's what it is asking. So I got a slide from a company. They make a good slide there. So if you look the slide number 13, just like how we write the multiplication table, they write the similarly. So maybe you can just easily do those. Yeah. So they write like aluminum here, this way, and maybe chloride here, and then they come to aluminum and chlorine in this box here, and this okay, aluminum chloride is soluble or insoluble, so they write that. So in 30, so that they make more easy. So I put that, maybe helpful. Yeah. Alright. So thank you very much. Yeah. So we'll do a little bit next week, and then we'll be ready for the exam. All right. Good. Thank you. Alrighty. Thank you, everyone. So, thank you again, Professor Kafle. Thank you very much. Thank you very much, everyone. Thank you very much. So, I stop this one. Yeah, so I stop this one.